Okay, Quantum 1 tutorial question number 10. Okay, we have a hydrogen lamp. That this is a lamp that contains hydrogen inside, and when the hydrogen is heated up inside the lamp, a gas that's heated up actually will emit lights. In this case, the hydrogen lamp, when it's heated up, is found to emit blue light. So there is a lot of photons of the blue light. The wavelength of this blue light is 4.9 times 10 to the minus 7 meters. Okay, when given the wavelength of the light. And we have a metal surface, and the metal surface has a work function energy of 1.80 eV. But notice that they give the work function in terms of eV. But when we use our formula, when we do a calculation, we have to convert everything to the base SI unit, or just the SI unit. So later on when we do calculation, we have to convert 1.80 eV to joules. How do we convert eV to joules? Okay, we just multiply this number by E, 1.60 times 10 to the minus 19. So 1.80 times 1.60 times 10 to the minus 19 will be the value in joules. Okay, so later when we do the calculation, we have to do that conversion. Then what happens when light falls on the metal surface? Well, we know from a photoelectric effect experiment, electrons will be ejected from the metal surface. Okay? The electrons injected from the metal surface will have will have a certain kinetic energy. The electrons will be fast moving electrons. Okay, some certain kinetic energy. When an electron is we learn that electron, when it's moving, it behaves like a wave. Okay? Photoelectron is just refer to electron. So when the electron is emitted from the surface, the electron has some energy, some kinetic energy is moving, but we know that a moving electron will behave like a wave. And here they want us to find what is the corresponding wavelength of this wave. Okay, that's of the electrons that's emitted from the metal surface and is emitted by the photon. Okay, so that's what they want us to find. Okay, but first we have to apply to the first situation, the photoelectric effect first. We have the incoming light. Okay, so according to the photoelectric effects equation, the incoming photon energy minus away the work function, okay, because it's the energy that's absorbed by the electron. So after using up the work function in order to come out from the metal surface, the remainder will appear as the maximum K of the electrons. So the first step is to find the kinetic energy of the electrons, and that is hc over lambda minus the work function. So we sub in the values. H is the Planck constant, c is the speed of light, wavelength is this value, then minus the work function. Work function is this value, but remember not to convert to joules. So if you do that, you work it out, you get 1.18 times 10 to the power minus 19 joules. So that is the kinetic energy of the emitted electron. And next step is to find what is the corresponding wavelength of this electron. Okay, the wavelength of the electron is given by the de Broglie formula is h over momentum, h over mv. So to find the wavelength of the electron, we have to find the speed of the electron. We have just found the k of the electron, so we just equate this k to half mv square. Then we can find the speed. Then we sub the speed inside here. M is the mass of electron, we sub inside here. H is the Planck constant, we sub inside here. We get the answer, the wavelength of the electron. Okay, 1.42 times 10 to the power minus 9 meters. Okay, so that's question number 10.